Memory consolidation is often imagined as a neutral recording system, but the brain does not store reality, it stores interpretations. When information first enters the cognitive system, the hippocampus binds sensory input with context and meaning. If the interpretation is inaccurate, the error does not remain temporary. During consolidation, neural circuits strengthen the interpretation itself, embedding it into long-term memory networks. Over time, the brain stops recognizing the belief as an interpretation and begins treating it as a fact. This transformation is critical. A false belief becomes resistant to correction, not because it was convincing initially, but because the consolidation process biologically stabilizes the error within neural architecture. Emotion is one of the most powerful stabilizers of memory. When the amygdala assigns emotional intensity to an experience, the hippocampus records that information with enhanced durability. The brain interprets emotional signals as indicators of importance, prioritizing those memories for long-term storage. If the original belief was inaccurate, emotional tagging still strengthens it. This explains why emotionally charged misinformation spreads so effectively. Fear, outrage, and identity attachment amplify consolidation. Once emotion binds to the belief, the brain defends it not only cognitively, but also effectively. Challenging the belief then feels like challenging the person themselves, which is why emotionally consolidated false beliefs often survive even overwhelming factual correction. Memory consolidation intensifies during sleep. As the brain cycles through sleep stages, the hippocampus replays patterns of neural activity experienced during the day. These replay sequences strengthen connections between the hippocampus and cortical storage regions. Importantly, the brain does not replay only accurate information. It replays whatever interpretation was encoded. If the brain accepted a false belief during waking cognition, sleep can reinforce that belief through repeated neural activation. Each replay strengthens synaptic connections, gradually transforming a fragile assumption into a stable memory trace. By morning, the belief may feel more convincing, not because new evidence emerged, but because the sleeping brain physically reinforced the neural pathway. Neuroscience describes memory strengthening through a mechanism known as long-term potentiation. When specific neurons activate together repeatedly, the synapses between them grow stronger and more efficient. This mechanism is indifferent to truth. It strengthens any repeatedly activated pathway. If a false belief is revisited, repeated, or socially reinforced, the neural pathway encoding that belief becomes increasingly dominant. Eventually, the pathway becomes the brain's default explanation whenever related information appears. Correcting the belief then requires weakening an already established neural circuit while constructing an alternative one. The challenge is not intellectual but structural. The brain must rewire networks that have already been biologically optimized. Mature beliefs rarely exist in isolation. Through repeated reinforcement, they integrate into broader networks of assumptions, memories, and interpretations. A false belief may connect to identity, cultural narratives, emotional experiences, and other beliefs that support it. This network architecture creates resilience. Challenging one belief triggers defensive responses from the entire system. The brain prioritizes coherence within its network over strict empirical accuracy. For belief revision to succeed, the brain must construct a new framework capable of replacing the old one without collapsing the individual's sense of meaning. In this sense, memory consolidation transforms false beliefs into structural components of cognition, shaping how the brain interprets reality itself.